welcome back. In this module, we are going to continue with the problems on continuity. What does the problem say? Examine the continuity of a function. If you have observed in this function something very carefully, what does it say? You have 2 points at which it is either continuous or not. You have to check. So, starting with the solution. Here we have to discuss the continuity of f of x at 2 points, and which are they? X equal to 3 and x equal to 6 respectively. So, the case 1, when x is equal to 3. F of x will be continuous at a point x equal to 3 if we know already this equation. What is the equation? Limit x is tending towards 3 minus f of x should be equal to limit x is tending towards 3 plus f of x should be equal to f of x at x equal to 3. So, moving ahead with the solution of a problem, limit f of x when x is tending towards 3 minus would be, in this case, when x is less than 3, the equation is x square minus 9 upon x minus 3. So, the x square minus 9 can be represented as x square minus the 3 square upon x minus 3. If you observe, it is of the standard formula a square minus b square is equal to a plus b into a minus b. So, the equation can be written as limit x is tending towards 3 minus x plus 3 into x minus 3 upon x minus 3. So, if x minus 3 is getting cancelled, the equation would be limit x is tending towards 3 minus x plus 3. But x is tending towards 3. So, the answer which we would get is 6. So, I can say limit x is tending towards 3 minus f of x is 6. Moving ahead with the second part of the first case. It is limit f of x when x is tending towards 3 plus when x is greater than 3. So, from the equation, we already have the equation as x plus 3. So, the answer is nothing but 6. So, I can say limit f of x when x is tending towards 3 plus is nothing but 6. So, the third case of it, that is f of x when x is equal to 3. So, from the given question, when x is equal to 3, the equation is x plus 3. So, limit should be x plus 3, and which is equal to nothing but 6. So, you observed something, 6, 6 and 6 in each case. So, I can say limit f of x when x is tending towards 3 minus is equal to limit x is tending towards 3 plus f of x, which is equal to f of x at x equal to 3. That is, all these values are nothing but 6. And when all are equal, I can say that the function is continuous at x equal to 3. Now, moving ahead with the case 2. F of x will be continuous at point x equal to 6 if limit x tends to 6 minus f of x should be equal to limit x tends to 6 plus f of x should be equal to f of x at x equal to 6. So, moving ahead with the first case, 6 minus. So, from the standard equation, if you want for x which is less than 6, the equation is x plus 3. So, in this case, answer would be 6 plus 3, and which is nothing but 9. So, limit x tends to 6 minus f of x is 9. Moving ahead with the second case, that is limit f of x when x is tending towards 6 plus. So, it is a right hand. So, from the standard equation, 6 plus is the third equation. So, it is limit x is tending towards 6 plus, and equation is x square minus 9 upon x minus 3. The equation can be represented as x is tending towards 6 plus x square minus 3 square upon x minus 3. So, by applying a standard formula, a square minus b square, you are already aware it is a plus b into a minus b. So, the equation would be limit x is tending towards 6 plus x plus 3 into x minus 3 the whole upon x minus 3, and x minus 3 is getting cancelled. So the equation which you have is limit x is tending towards 6 plus into x plus 3. So when x is equal to 6, the answer would be 6 plus 3, and which is nothing but 9. Now the last case, that is limit the f of x at x equal to 6. So for that third condition, from the question itself, we have the equation, and as we have solved it already earlier, that is by a square minus b square, it would be a plus b into a minus b. X minus 3 is getting cancelled, and x plus 3, where x is 6 and it is 9. So I can say that all the three values, that is limit x is tending towards 6 minus f of x, is equal to limit x is tending towards 6 plus f of x, and which is equal to f of x at x equal to 6. So hence I can say that the f of x is continuous at x equal to 3 and x equal to 6. So I can say the function is continuous at both the points. So students, mark this problem very, very important. See you again in the next module. Till then, rise and shine. Thank you.